Hello everyone, I am here in this video to talk about uniform probability distribution. And this is in your book on page 274 of your textbook. So let's just talk a little bit about the continuous uniform probability distribution. Well, I think a great example of a uniform distribution is if you're on an airplane. So if you've flown on an airplane, you know that you take off, and then once you reach your cruising altitude, it's consistent. So you are consistent at that cruising altitude for whatever part of your flight, and it doesn't change again until you start to descend, right? So everything is consistent. And so uniform, that's pretty much what we're talking about. And uniform probability distribution is one of my favorites to calculate because it's pretty much just a square or a rectangle. And we know we were to find the mean. The mean in this particular case is equal to A plus B divided by 2. So it's just, the mean is the averaging the two together. And for this, it's pretty much really important to know that the probability density function for this is 1 over b minus a if x falls between a and b. If x falls outside of a and b, if anywhere outside of a and b, it's going to be 0. So with a being the smallest continuous random variable and b being the largest continuous random variable. So when we're calculating this, we can just say the probability. We're looking at the probability of x being between, I think the book calls it x2 and x1. And that x1 and x2 are going to fall between, they're going to be equal to, greater than or equal to A and less than or equal to B, right? And that this is going to be equal to x2 minus x1 over B minus A. And so let's look at the example that's given to us in the book. I'm going to change my pen color. I'll change it to green, like green. And let's say the book tells us that they're talking about being at Deerfield Golf Club again, and that that playing around golf follows a uniform probability distribution, with the maximum time for playing around being 4 hours, and the minimum time being 4 hours, which is 240 minutes, and the maximum time for playing a round of golf is 4 hours and 50 minutes, which is 290 minutes, right? So we're going to say in this particular scenario, the A is equal to 240, right? And the B is equal to 290. So this is 4 hours for a round of golf, and this is 4 hours and 50 minutes. So A and B, right? And so if we were to ask, in this particular situation, we know that our f of x is going to be 1 over 290 minus 240, right? Equal to 1 over 50, correct? And that's 0.2. And that is our, is that right? 0.02. And that is going to be our probability density function, right? And so now, we also know that the area under the curve is always going to be equal to 1. So let's talk about solving one of these problems. So given this particular situation, we are being asked on page 275, it says, they want to know what is the probability that a round of golf is going to fall between 2 hours and 240 minutes and 252 minutes, right? So given that information, so we want to know what's the probability that a round of golf is going to be less than 252 minutes, right? But greater than the 240 minutes. We know that is equal to 252 minus 240, right? Over the 290 minus 240. And that is going to be equal to 12 over 50, which is equal to 0.24. And there we have it in terms of finding the probability. There's a 24% chance that the next round of golf is going to be completed in less than 252 minutes, which is 4 hours and 12 minutes. But, greater than the 4 hours. So this is all explained to you in the book on page 275. Just want to demonstrate the calculations and give you a different perspective or an oral perspective on calculating these problems. If you have any